Okay, so welcome, and now we're going to start talking about secant and cosecant functions and analyzing their graphs. So let's start with secant. Now, in order to understand secant, we're going to look at the cosine function. Okay, now why would we do that? Because the cosine function is reciprocal. Is the reciprocal of the secant function. So again, secant function is, we look at it as a reciprocal function because it's 1 over cosine theta. Okay, so if we look at the behavior of the cosine function and we look at the secant function as a reciprocal of the cosine function, we can get some information on how to graph this thing. Now, notice that, okay, so here, cosine theta. When cosine theta is 0, this thing is undefined, which means we have some vertical asymptotes. So where do the vertical asymptotes going to occur? Whenever cosine theta is 0. Where does it occur? Well, at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So basically it's going to be any multiple or odd multiple of pi over 2. So that's going to be these. So I'm going to put in the asymptotes. Oops. Missed that one. Okay, so there are the asymptotes. Now what else can we say? Since they're reciprocal functions, as cosine, well, the maximum that cosine is ever going to be in absolute value is 1, right? So in absolute value, the largest this is going to be is 1, which means that the reciprocal says that the largest, or excuse me, the smallest that this will ever be in absolute value is 1. Okay, because if the largest this is going to be is 1, and this goes from 1 to 0, that means that this is going to go from 1 to either positive infinity or negative infinity, depending on the value of cosine. So if cosine is positive, this thing is going to be a minimum value at 1, but then it's going to go to positive infinity. So as this is going down, so as the cosine function is going down, the secant function is going up. So what is it going to look like? Well, it's going to look like this. So it's going to intersect with the cosine function at the maximum and minimum values, at the extrema. So, but then it's going to look like this. Okay. So on the ones where the cosine function is above the x-axis, so is the secant function, but it's going to be a U-shape. Okay. And then when it's below, it's going to have a downward opening U-shape. And so the graphs in blue represent the secant function. And notice that it repeats every other one, it repeats. Okay, so what else can I say about the behavior based on the cosine function? Okay, so what does this, well, we know, again, so, and this obviously is from what I just said, is that the asymptotes will be at where the cosine function crosses the x-axis, which is again when it's 0. Okay? The secant function is also an even function because cosine is an even function. Let's see here. Anything else? I think that's it. So here are the characteristics. And I'll just notate them right here. So the first one is, again, the stretching factor is going to be A. So I'm going to write this as the general secant function. So, and again, I'm going to start out with the simplest one. So that's going to be y equal to A secant b theta. And so A is the stretching factor, right? So A is our stretching factor, as usual. And then the period. Now, in this case, the period, because again, it doesn't repeat the pattern for what? 2 pi, right? Just like cosine. So that makes sense. Cosine is a period of 2 pi. Secant also has a period of 2 pi. So the period is going to equal 2 pi divided by the absolute value of b. Again, same reasons as before. Now, the domain is going to not include these asymptotes. So where do the asymptotes occur? Well, for this specific case, it's going to be very similar to what we did before. So it's when we take half of the, well, a fourth of the period in this case. Okay? So it's going to happen, the asymptotes are going to occur, or well, let's do the domain. Okay? The domain is going to be when what? X is not equal to, because it's all real numbers except x is not equal to pi over the absolute value of b divided by 2. So it's going to be pi over 2 times the absolute value of b, okay, times k. So any multiple, so what is k? K represents an odd integer again, okay? So where k is an integer and odd. So this symbol is the boldface z, which is the symbol for the set of integers. So again, what I'm saying is k is an integer and it's odd. So it's an odd integer. Okay, now also, this is where the asymptotes occur. Right? So this is where all of the asymptotes occur, the vertical asymptotes. The range is going to be, now, here we have to be careful because again, what's cut out? The part of the range that is cut out is this band right here. Okay, so the A, again, affects the amplitude, right? Think about the cosine function. It's going to affect the amplitude. So where does it start? Okay, so in this case here, the range is going to be the union of this side and this side. So the union, so the range, okay, that's going to equal the union from negative infinity to what? To whatever A is. Okay? So it's going to be the negative of the absolute value of A. And the reason why I put it in absolute value is we don't know whether A is positive or negative. So we're going to say the negative of the absolute value of A, and that's going to have a square bracket. And we're going to take that, the union of the positive value of a to positive infinity. And so that's going to be the range of the secant function. There is no amplitude when it comes to the secant function. So when we talk about amplitude, I'm referring strictly to the cosine function. Okay, but there is no amplitude for the secant function. Okay, and again, this is an even function because cosine is an even function. Okay, that's it. Have a great day.